Hello, thank you so much, Navati. That was an amazing introduction. So let me just get my slides up here. I've got a really interesting demo just for everyone today. I really wanted to go over a few things. I'm doing a lot of really interesting things just in my day job at Loblaws with Navati, and also just a bunch of different things that I'm doing on my spare time and with a few companies that I'm involved with. And I'm seeing a lot of trends. So I thought today that, we could discuss some of them and go over potential futures in mobile development and where things are going. So let me just share my screen here and I'll put up my slides. That's actually not going to work. Okay, can everyone see the slideshows? Navati, we're good?
Yeah, we can see it.
Excellent, excellent. So I'm Scott Larose. Today I'm going to be talking to you about in bracket potential future for mobile development, because it's always hard to predict the future. So an introduction. So I started out my career as a Queen's graduate here in Canada. Queen's is a university that's somewhat internationally well known in Kingston, Ontario. I graduated in 2013, and I quickly transitioned into the workforce. And I immediately went into iOS development. I sort of flirted around a bit with some web development. And then in the last, I'd say 3 to 4 years, my time has basically been very evenly split between the two platforms for iOS and Android. I'm currently working on a lot of really interesting things going forward. So that's why there's sort of a question mark there as to, what's next. So currently, during the day, I'm a staff developer at Loblaws Digital. For many of you who don't know that, that's one of the largest grocery store retailers here in Canada. During the nights and weekends, I'm actually transitioning from amateur to professional photographer. And I also help running a company called Potcat Incorporated. We're actually a full service production studio. We've got a bunch of different 3D printing technologies, film production, and content creation. And I'm basically trying to get that off the ground with a few other individuals here in the Toronto film scene. And we're doing a lot of really cool things. The idea that I came up with for this company was basically integrating a tech company with a more traditional production company. So we actually have a few cool things. We're wrapping up our first short narrative. And we're also building a very large 3D printer farm to do things to assist us with printing props for other people's projects. And we're looking to start production on our next film next summer. I really wish you could check us out on social media. We're super early stage. And unfortunately, I don't have any of that set up. I don't even have my personal social media set up. I sort of fell into this trap where I was in the middle of getting rid of the old and creating new accounts and new branding. And I just haven't had time to fully commit to the new stuff. Definitely check out our website at potcat.com. It's currently under construction, but in the next few months, I'm going to have some time probably just as I wrap a few things up with editing our first film. You'll probably see more of that. And that'll really be the best way to get an idea of what's going on and the sort of things that we're up to. These are just some photos from our production that we did. Just so it's pretty interesting. We had a lot of really cool prop work, a lot of really cool hardware and whatnot that we had to build from scratch. So today I'm going to be talking to you everyone about a potential future for mobile development. So that was the original title that I wanted to hand off to Ciara there, but unfortunately that's very ambiguous. And so why so ambiguous, right? Well, predicting the future is sort of a fool's game, and often I just don't. I just avoid doing it completely. There have been so many things that I thought were really interesting and going places, and then they just sort of fizzled out. However, there have been a lot of recent trends, and throughout my sort of 10 years here in mobile development through Android, iOS, and a little bit of web sort of peppered in there. I've noticed a lot of really interesting things, and there's a lot of interesting things happening and changing. So we've got native observables finally coming to iOS. People are finally taking GraphQL fairly seriously and looking at ways to properly scale it and implement it in the production world. And basically for mobile and a big portion of web, declarative UI is kind of taken off, right? And of course, we have our architecture. It seems like everyone still is fairly obsessed with architecture and the different types of architecture and debating what paradigms work best when and whatnot, right? So I really sort of see the industry, especially from a mobile standpoint, really coming to a point and coming to a head with a bunch of different, really interesting maturing technologies. And I'd really like to take this talk as an opportunity to just discuss some of these with you. And I've got some demos just to demonstrate some of the things that may be possible in the very near future, and some of the things that we can already do with these technologies, but they just really haven't been standardized, right? There's no industry standards like there are around things about like REST or a lot of these other technologies that we use in our day-to-day. And I really think it's interesting because, all of us, if we're professionally developing for web or mobile platforms, we're going to have the opportunity to work with these and mature these. So it's a very interesting time to be the kind of developer that we all are. So first we have to see, where we're going. I talked about how predictions are very inaccurate, often fool's game to predict the future, right? So to really look at where mobile is going, we really have to look at where it's begun. And we have to start to think about, where do mobile trends start? I've always sort of envisioned mobile development as this sort of weird space that sits in between web applications, native platforms, so like your old school C, C++ apps, driver applications, stuff like that, that you would create for Windows, Mac, Linux, terminal applications, CLIs, all that sort of stuff. And then, of course, you have your cross-platform applications, almost in sort of a pyramid, and mobile, or a triangle, and mobile really sits right in the middle and sort of borrows and lends and steals from all of these different paradigms and come up with some really interesting implementation solutions. And when I say cross-platform, I don't mean cross-platform in terms of cross-platform mobile technologies. I more mean like how, Chromium's taken off, and how, Steam applications and Slack are written basically in web languages, but then you can get an executable from it and run it on your desktop. So I really see that mobile is really free to sort of take inspiration from all these three different areas, but it definitely almost always draws heaviest from web, right? We saw that with React Native, declarative UI, so many things are borrowed over, so many different mobile cross-platform applications are basically just web languages or variations on web languages. It's definitely been a repeating pattern through the last 10 years of development that I've seen, where web development is very heavy in trends and fads. It kind of goes back and forth, things get kicked around. Is this a trend? Is this a fad? Should this be standardized? And then when web development's really sort of gotten through with it, often these trends become standardized in mobile. It's almost like the mobile development sphere sort of uses web development as some sort of like guinea pig or test ground to see what works and what doesn't work, and then picks the best technologies that would work in the mobile paradigm from that. So with that said, right, what exactly has been going on in web lately? So because of the company that I run on the side, and because I'm constantly creating web applications and mobile applications, I've really got to keep knowledgeable about all these different things. So we have a lot, there's definitely been a trend in web to have a lot of high performance web frameworks powered by functional languages. So Erlang, Elixir, you see a lot of these different functional languages because they're so responsive. They're so good at doing a lot of these tasks that you see on mobile when you're developing code for like server backends. It's something that's that's really great, and I wish would be used a bit more when developing, mobile REST applications. And we are seeing that as well when you want high performance and you want, low latencies, and to be able to just, spin up an instance somewhere, anywhere around the world, and support a mobile application or a few thousand users, depending on your business needs. Web has definitely been doubling down on declarative UI. React Native, things like that have just been trending since I think 2016, 2017, and they're just not slowing down. Single page applications recently have become very big. I'm not 100% sure if that's just a fad, but it is definitely something to mention and take notice of. Coupled architectures. So for a while, everything was just decoupled, everything had a decoupled backend, and now you're sort of seeing people move a bit more because we figured out some of the security restrictions and some of the limitations that we ran into before as web developers. You see individuals move back to having architectures where your client is a bit more closely coupled to the backend of your web application. And also something that I'm really interested in is Node.js applications. So back to the first point with Erlang and all of that, and a lot of these functional languages that operate very quickly, provide very slow, turnaround time on requests and things like that from your server's backend. We're getting to the point where some applications don't even need client-side code. The code that you pump down the pipe is so responsive that you don't really need to have anything running on the client to do any processing. So as I mentioned, what really piques my interest are the functional languages. I love functional languages. I love the fact that when I'm working with things like Swift and Kotlin, they have a functional aspect to them, and that when you go and use it, you get it really adds a very nice sort of layer of cleanliness to your architecture. If it's mostly OOP or another paradigm, functional always, for me at least, cuts down on errors and basically makes a cleaner, more testable code base when you try to use functional, obviously appropriately, and where you can. So specifically, one of the frameworks that I really like, and I'll be talking a bit more about it later, the Phoenix framework with its live view, which operates on the sort of leaks system. Those are the files that you'll see. And they do a lot of really, really interesting things with WebSockets. So I find WebSockets very, very, very fascinating. I liked REST. I like REST. I thought it was, I think it's definitely improvement on SOAP. If any, maybe I'm showing my age here, but if anyone's ever worked with a SOAP backend when you're doing mobile work, it's an absolute nightmare. And the fact that REST is so stateless and it has a very standard, easy to implement design pattern, and most frameworks, they have a module to support some sort of micro API services that are all REST based. It's nice, but I feel like we can innovate on that and potentially move on. So why not? Let's take a look. So we have the Phoenix framework that I'm going to be demoing today. This is a web framework. It runs on Elixir, which is based off of Erlang. So just give me a second here. And here we go. Navati, let me know if my screen just goes blank or something.
Sure thing.
So we basically, I just want to basically go through a quick demo here, describe what the demo is doing on a very high level, and what some of the implementation ramifications are for this. So if anyone,
you are still showing this slot, your browser.
Yeah, so do you see two browser windows?
No, just one.
Nope, just a slide deck.
Oh, really? Okay, sorry about that. I'm just going to reshare if that's all right.
Yep.
Do you see two Phoenix framework windows?
Yep.
Excellent. Sorry about that, folks. So this is the Phoenix framework in action. So Phoenix framework is, as I mentioned, a web framework. It runs off of a language called Elixir. That it is a pure functional language. It kind of reminds me a bit of Ruby. The Phoenix framework has done something really interesting with their feature that they call Live View. So what Live View does is Live View actually allows you go on and you do your regular old HTTP handshake. So you go to the website, you do get, localhost 4,000 posts. This is the URL that we're working off of now in the port. It gives you that standard HTML. And then what it does is it actually creates a socket connection, a WebSocket connection, and it does bilateral communication after that and going forward. And it's a single page application, which means that you have one DOM, and the WebSockets themselves actually go and manage what needs to be replaced and what doesn't need to be replaced in the DOM. But I'll get to that a bit more. So Phoenix was designed for specifically having real-time applications. So here we have two clients connected to the same Phoenix backend, and what this basically is a really quick and easy put together demo that a lot of people do when showing off the Phoenix framework. It's basically just a Twitter clone. So you can go here. Let me just, sorry, my zoom's in the way. So you'll notice some interesting things as I sort of just go through some of the functionality here. So we can create a new post, code. And if you saw that, it shows up immediately on the other side of the client. The other side of the client, the other client that's operating here doesn't have to do any polling, nothing like that. Because of the bilateral communication, all that you're limited by are network latencies and basically the speed of light. So we can further demo this. That you see it immediately show up here on the left-hand side. Retweet. It's all very, 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 very quick, easy to do. We create another post over here. And there you go. You see it just right at the top. So it really does give you the best the best real-time experience that you can really get, working off of the technology that we have today, right? Fiber optics and regular servers. So we're really seeing with single page applications and actual WebSocket connections, truly real-time communication. So this is, just going to switch back to the slide deck here. Navati, I'm good?
Yeah, you can see it.
Excellent. So yeah, so the Phoenix framework built off of functional languages, so it's super quick and efficient. If you actually look at the latency times, I was blown away. Even when we went and put this up on like an AWS instance, we were still talking in like very small milliseconds and sometimes even microseconds. When I test on my machine, it's usually like 1 or 2 microseconds. That's it. Which is incredibly fast if you were to look at something like Rails or Ruby on Rails or even React Native. And this, of course, Phoenix framework was created because of the lack of real-time communications between web clients and web applications. So what exactly is going on here? I described this a bit before. So it's a single page application. You have the DOM, your web APIs. What they do is they communicate just standard JSON, and you basically have element IDs on the page. So when I go and click that like button, what's happening is it's really just going through there and saying, okay, a like was increased. And then Phoenix broadcasts it to all the other users that can see that have the access to see it. So all their other live clients, you can limit the scope, whatever. And then from there, what happens is it basically goes into the DOM and just scalpels out that one field and then replaces it with the new value. So that creates a lot of really interesting things. You no longer have to rely on these big bulky REST requests and responses. You basically get a protocol to do bilateral communication that's baked into the Phoenix framework, and you can do things so quickly that you don't need JavaScript to actually go and change these values. It's very interesting, and it creates a much more responsive experience on almost all levels. So the sources for that, first off, just big thanks to Chris McCord. He's the creator and the major contributor to the Phoenix framework. The chirp demo repo, so you can go and try this out yourself, just located there. And then the Elixir forums, always helpful. You're doing anything with Phoenix or Elixir, jump in on the forums and make sure that, if you run into any problems, everyone there is amazing. And I've been spending a lot of time on there lately. They'll help you out a lot. So that's all great, but we're not web developers, right? This is not a web application talk. It's not the future of Phoenix or Erlang or Elixir. It's the future of mobile. So LiveView and WebSockets, they all make amazing real-time applications. As networks get faster and faster, we see more computing power get pushed to the servers. In the next 10, 15 years, things like quantum computing is going to come down. We're going to have massive amounts of parallelism through our computation coming into our society, which is going to have massive ramifications. And we're all going to want these things real time, right? We already want that as a society. We want the same day delivery. We want to order our soap from Amazon at 9 in the morning and have it show up in 1 in the afternoon, right? We want to be able to order things. We don't want to get bogged down by traditional problems with network layer. 5G's coming in. It's a much stronger infrastructure. So there's a lot of problems on mobile just looking at it from a purely real-time experience. Push notifications are unreliable and often not in real time. We see that mostly on iOS, sometimes too on Android. REST, if you want to do what I just showed you and you were operating off of a standard REST backend that was talking to a JavaScript client, you'd have to be continuously polling, and you would probably have to replace almost the entirety of your DOM, which just means you're just losing data, right? So the question really comes, and had me asking when I saw that demo and when I worked with Phoenix a bit, is could we create a sort of WebSocket paradigm or a sort of LiveView single application for a mobile platform? And so originally, I asked that question, and my sort of knee-jerk response was to try to just hook up basically hook up a mobile client to the Phoenix backend. That had some issues though with how that they set up their socket sessions and whatnot. But I actually was able to get pretty far with a tool called Vapor. It just helps you set up quick and easy backend clients using Xcode and Swift. And I was able to basically reproduce the demo and make it pretty much a single page application that operates very similar to what we just saw, so Phoenix and LiveView, but on the iOS platform using Swift UI, observables, and a few other things that I'll talk about after. So I'm just going to do the second part of my demo here. Let me set up my screen. Navati, I'm good.
So I can see a lot of things. Yeah, I see 2 of your simulators.
Yeah, let me maybe close some things here. It's a bit distracting. There we go, something we're all familiar with. Yeah, so I basically went and set up the Swifty Chirp. I call it the Swifty Chirp demo. And I just did it. We've got 2 Swift clients here. This is actually the WebSocket backend just here in the background. And yeah, so it basically operates the exact same. There's a few more things that are stubbed out. You create a new post, you see it immediately show up in the other client in real time. And you can tell that it has the identifier. So this is message 2. We'll see message 1 over here on the left. And it basically just adds it to a very, oh, my bad. It basically just adds it to a very poorly crafted UI. But it really goes to show that as these technologies mature on web and we see what is and isn't possible and what does and doesn't make sense, these types of things are going to be showing up more and more in mobile. And I'm really excited because I can't tell you how many times I'm using an app that isn't using WebSockets or isn't using some sort of a push technology or bilateral communication. And it's just you're constantly refreshing, you're constantly pulling to refresh, you're constantly, having to basically fight the experience to get what you want out of the application. So it's really interesting just to sort of see both these things show up. And I just want to talk about some of the advantages and disadvantages of a potential real-time, live view-esque framework on a mobile client and some of the problems that I encountered while implementing and doing this demo, and some of the things that it worked well with and some of the things that didn't work well with. Unfortunately, for all you Android devs out there, I'm going to be talking just in terms of Swift and iOS and that sort of ecosystem. Let's go back here. So yeah, so I think we did answer that. Oh, sorry about that, Navati?
No, I was just giving confirmation. We see your slide.
Excellent, thank you. So yeah, so could we potentially make a live view single application for a mobile client? By all means, yes. Really, the only limitation is WebSockets, and that's more than available on Android and iOS right now. People are using it for chat clients and a number of different things. So there's no hardware or technological restrictions for that right now. The advantages and disadvantages. So this demo was, it was tough. Like I said before, I originally looked into doing it through, just connecting the mobile clients directly to the live view and sort of, faking in a sort of headless browser approach that it was a actual live view page with live view markup and JavaScript enabled and all that stuff. And then that didn't work out. It actually turns out that original socket that you get from Free Phoenix is actually pinned to the browser window itself. So you really can't do much with that, with the exception of literally just running a web view or a WebKit view and basically interacting with those protocols. So you click on a button, then it just forwards the click to the actual web page. And that just seemed like A, a lot of work for a demo, and B, not a solution that would really go anywhere if you ever tried to implement that into production. So what I actually ended up doing is I just wrote a very quick and easy sort of bilateral protocol, whipped it up in Vapor, and then I did, thank God for Swift UI, I could just whip up a list view and then basically just use that communication protocol that I'd established between the server and the gateways and the network layer on the application of the demo to basically just replicate the functionality of Phoenix and the demo that we saw originally. The only major things that I actually really had to implement were pretty complex broadcasting system so that you could broadcast all of those different changes of those individual rows to all the different mobile clients. So those were some of the problems that I faced while doing this. The good parts about this, the advantages, is this works really well with clean architectures and observables. So you can literally have like bilateral communication that just updates an array of objects, something in a database, whatever. And then if you go and observe that with an observable, you can basically pipe that to any layer in your in your mobile architecture. So you can go from your network data layer and pipe that directly to the view, although I wouldn't advise that. Or you could pipe that, to your presentation layer, your view models, your presenters, depending on what you're working on. Or you can just use that data internally in the network layer to do a bunch of different things. Maybe you want to sort some stuff and then put it into a database. You're having a data collection app, whatever. So it's really robust with clean architectures. The only thing that doesn't work so well, or is a bit of an eyesore, is you basically have to keep your architectures, your backend and your front end architecture, very closely coupled. And that's actually one of the major complaints that people have with Phoenix in general, is because you don't need to have basically JavaScript clients. You don't need to have any client-side code when you're working with WebSockets that operate that quickly. You basically get a front-end view, or you basically get client code that needs to know a lot about the backend and the services and the WebSocket services that are being run, and then vice versa as well. So you create a very hard dependency there, and that's being debated right now in web. If people want to go back to more coupled architectures where you can have one or two devs basically do all the full stack work on it, or do you want a back-end web developer to do all the APIs and then a front-end developer to implement the designs and the client code? There's definitely disadvantages of both. On mobile, we often all prefer very, very decoupled architectures, right? We have to interact with something most of the time that's off-site. We can't have the server go and make changes in the actual client code. That's just impossible. There has to be an interface between mobile and the backend. And unfortunately, when you do this bilateral communication through WebSockets, you end up creating these weird dependencies where you need the same models. Your client and your backend need to be speaking the same language, and that can often result in basically the exact same code being written on your client and your backend. However, that was a problem before as well, when we were working with things like SOAP, before pre-REST, SOAP APIs and whatnot, and these sort of stateless APIs. So I don't think that it's more or less a problem of the actual technology, but something that developers like myself and individuals who are here now, we're going to be working towards in the future, where we have a sort of standardized architecture for WebSocket communication between mobile clients and backends, basically like a REST, right? A REST where you've got a listener and you've got a listener and something that's receiving, and your server and your client can basically talk back and forth seamlessly. And I think that's where it's probably going to be going, and that we may in the future actually see a departure away from things like REST, where where it's this very rigid request response communication that we see, right? It's give me user object with credentials XYZ, and then return something that I'm completely expecting to come back. You can do all that with WebSockets. I just feel like no one's really cracked the best way to do that with WebSockets over mobile yet. There are some frameworks that exist. There are actually some functional frameworks that exist just to create web APIs, WebSocket APIs. And you can totally write your own using Vapor and play around with that, and contribute to these communities as they sort of start to grow and take off. But I definitely think that it's very interesting to see how quickly and easy I was able to do that just for a demo, and how seamless the real-time communication was. I mean, I'm not on the other side of the planet counting latency to see when that chirp post showed up, but it's really interesting when you dig through the network stack, and you start monitoring this, and you actually see the communication going across the wire, and you start looking into the wire, and you see that, wow, not only are these things happening incredibly quickly, but when you build your mobile application from a sort of single page application perspective, which is happening a lot in Android actually, you see too that the amount of JSON you need to support these UI elements is very small and minuscule. So you just get the number for the light count. and an ID, and then the client knows where to put that. So I think this is something very interesting, and I think that this is definitely going to be a part of, you know, future development and how we develop those interactions between the front-facing mobile clients and our backend APIs. Like I said, it works. It really jived well with declarative UI. Really jive well with a lot of the asynchronous technologies that are being developed on mobile platforms right now. And things like, you know, your observable objects, React, Combine, all of those different paradigms mesh really well with this, because you can request something from the server, you know, update it in your data layer, and if that value is being observed, then everything else in your application that needs to know that that value is changed just changes it. And that's basically how I implemented this demo. So that's everything on my end. Just to conclude, I really think that we're going to be seeing a lot more backend APIs that support mobile applications, being written in functional languages. So that's languages like Elixir, Erlang. I'm pulling a blank here. Lambda, a few other things. Pure functional languages. If you have no experience with that, I'll definitely recommend looking into it. It's very eye-opening. And if you're still working with primarily, you know, OOP and a lot of these sort of other paradigms, I tend to think of the functional paradigm and paradigms in general as, you know, a tool in your toolbox. And if you have that tool, it's an advantage. If you don't have that tool, then, you know, you're confined by the older things that we do before. But I'm by no means saying that, you know, we need to get rid of all of OOP or anything like that. I just think that there are definite areas where functional languages outperform more traditional languages on both the mobile clients and on the backend services that serve them. And then also too, is I really do feel, maybe not so much in mobile, but definitely in web, single page applications are going to be taking off. And we're really going to see like streamlined network communication. So it's no long gone, I feel, are the days of these monolithic JSON objects that are just plagues on network bandwidth. We're going to see, you know, a few lines, update this value, that's it, with this selector code, route to that code, figure it out, and then basically scalpel out that value in your DOM or your mobile application and put it back in. Yeah, and I think that that's really going to drive the idea to go more towards, you know, having a UI view or a UI view controller or some sort of parent structure that just is constantly switching things out, rather than having all these different views in your view stack for mobile development. So yeah, so that's basically everything from me. Like I said, I use Swift UI for this. A bunch of vanilla Swift. The architecture that I chose was just like a very scaled down MVP, used gateways, all protected by protocol, super testable. Didn't do anything that, you know, wasn't basic clean code and clean architecture. And surprisingly enough, after I got the data layer working, it worked. It played really nice with everything. So I'll go on to questions here. Anybody feel free to ask any questions. I'd love to give some answers.
So we do have a question from Hui. She wanted to know, where is the WebSocket server hosted for the application that you demoed to us?
Yeah, so everything's just hosted on my local machine. So obviously it's a lot faster because it's on the local machine. But I have worked with Phoenix applications that are hosted elsewhere, so AWS, and you can basically pick anywhere you want with that, and it is much faster than the other architectures that we've had.
Okay, great. Also, I'm curious about like, how would could you tell us more about single page applications, and what would single page applications look like in mobile?
Yeah, so from a developer's perspective, potentially they could look like nothing. It could be the exact same, right? When you work with Phoenix and you're like writing your like HTML pages, that's exactly what you're doing. It's really all just you know, sugar under the hood that goes and hot swaps out these elements. With that said, though, working in Android and Kotlin, You see the trends in there, where they've gone from basically having pages that are just of a bunch of fragments, and before it was I forget the name of the UI component, but you were basically using like the controller component, and a controller component mapped nicely to one page. And then the community started going towards just having different fragments or view components on that one page. So it could also look something like that. And that's already standardized in Android. So Android's definitely ahead of the curve on iOS, because we just sort of went towards declarative UI and having like a body that's very similar to a web page. And it was like you have a view controller for everything, right? It was view controller for this, view controller for all your modals, and all these different things. So it could be something that sort of looks like that system, but is optimized for development, but under the hood is literally just one construct that's constantly switching things out.
Yeah, we also have a question. Have you worked with Kotlin multi-platform? And you did talk about a bit about Kotlin. And do you have any opinions about it?
About Kotlin? Yeah, so I'm not sure if I've worked with multi-platform. I'm just gonna have to go and say no, I probably haven't. The name does not ring a bell. But yeah, I have say a 3 to 5 years experience working with Android. And I enjoy Kotlin. I enjoy Kotlin just as much as I enjoy Swift. There's pros and cons to both. Kotlin feels a bit more ham-fisted from but I feel like everything that I hate from Kotlin, when I dig in to find out why I don't like it from Kotlin, it's usually just, well, it's based off of this in Java, and we've got to support this for legacy applications and whatnot. And then my initial complaint is usually, why is Kotlin doing something that's so Java-esque? So Java is sneaky. It gets in everywhere. And I wish Kotlin was created in a vacuum. And that's what I really like about Swift is you see very few remnants. They basically got rid of all remnants of Objective-C from there. I like Kotlin for different reasons than I like Swift, I guess, but I basically like them the same. They're very similar. They're not, you're basically comparing apples to apples at that point.
Also, I was wondering, like, how would this change the way we approach async programming in general?
So that's a very good question. So so it completely changes the way it's basically a complete real-time async paradigm, right? It goes from you ask a construct, a server for something. You say, hey, give me all the users from this ID. You wait a bit, and then you get a response, right? It's always this request, response, request, response, request, response, right? With bilateral communication, you're constantly just getting notices from a broadcast that another user updated something and it impacts the view that you're looking at, right? You're constantly getting these asynchronous events. And because WebSockets, they're very similar. If anyone's done any work with like raw sockets or anything like that, you have like a solid connection, right? It's basically you connect to an off server in the same way that you would connect to like port 900 through like Telnet or something on like an old CLI application, right? So it's a much more sturdy connection, but it gives you the opportunity to get updates anytime. There's no polling, so you don't have to poll. And when you get those updates, you can very easily just put them into dictionaries, arrays, and then make those observable. And then your entire application is immediately notified when anything changes. And depending on the state of your application, if the user's looking at that screen, you can deal with that data however you want. So to sort of summarize that answer, I think that it's definitely going to empower a lot of the trends that we're seeing now with combined and observables and stuff like that. But I also think there's going to be a bit of a backlash because it provides the potential for developers who are less experienced than others to really make a mess of the application, right? you can go and basically directly get something from a WebSocket and just hem-fist it into your view, right? Your view layer. And that's never good. And the repercussions of that on mobile are far greater than if you were to do that on web. So I feel like it may have a period of, there may be the dark ages of the whole sort of reactive paradigm. But I really do think that it will, to use this effectively, we will have to come up with some sort of standard practices. And I personally want to see those standard practices developed. I think Navati and I both know, working with applications that have misused things like React, like RX Swift and RX Cocoa. It's not fun. It's hard to test. It's not clean. You're crossing boundaries. You're making mistakes. So I really think that it'll have a very interesting effect on asynchronous programming. But I feel like the trends that are emerging, it works really well with. So it'll most likely we'll most likely see growth in those areas and building off of those things.
Okay, that's really exciting, and this talk was very insightful. So thank you so much for that. Thank you for sharing your insights on and all those experiments that you've been conducting. And yes, those were the questions. And also, I'd like to thank everyone who joined us. I hope you guys join us on Thursday and Friday for the Women Who Code Connect Forward, and also for our upcoming events. Everyone's thanking you there.
Thank you so much. I hope you enjoyed the talk. This is actually my first talk. I hope it didn't show.
Also, Sierra says you should look into Kotlin multi-platform.
I'm a big fan. That needs to be the future of mobile development for everyone.
What exactly does it provide? Fill us in.
You can like pull out your logic and share it between iOS and Android. And so in my personal opinion, if I was writing my talk on the future of mobile development as an Android developer who loves Kotlin, I'm a big fan of this idea of pulling out that logic, pulling it into that shared module written in Kotlin, because Kotlin is amazing. And then writing these UIs natively in Jetpack Compose and SwiftUI, because it's so much faster for both of those frameworks to build out that UI. So, and then for that Kotlin multi-platform, and I have not dove as deep into it as I wish I had the time to do. It can be also shared across like desktop. You can pull Kotlin multi-platform like into web as well. It's really cool, or has a lot of potential. We'll see where it goes. It's also very new in its life, but I'm certainly excited about the potential of that.
So I briefly mentioned like cross-platform. So how does it do that? It just can compile to like a bunch of different framework types?
Yes. Yeah. I don't totally know how it works on iOS because I do not have much background at all in iOS, but I know Kotlin obviously has the support to compile down to JavaScript, and I have heard that it does compile down to a fairly efficient JavaScript. I also don't have much knowledge of what fairly efficient JavaScript is. So they already had that support with Kotlin JS, and so just kind of pulling that out and being able to share across is really exciting. And I think extra exciting on the Android side, since Jetpack Compose can also be shoved into web as well. And so we could write the entire stack of web, desktop, Android, Jetpack Compose, all that logic in Kotlin multi-platform potentially. And I think that's really cool.
Thank you. Yeah, it's really interesting. There's so much going on. And we're also fortunate and privileged to be working in this space, especially right now. And yeah, cross-platform has always been a big thing. A lot of people interested in it, and there's tons of applications, React, and all these sorts of things. I'll definitely have to dig into Kotlin multi-platform for sure.
We'll host you again next year, this time on Kotlin multi-platform. Put it on your calendar. See you 12 months.
Yeah, we have a sequel for this talk.
I'll start off. Forget everything I said 12 months ago. Drop everything you're doing. Learn Kotlin. Nothing else.
Yeah, thank you. I have so much to reflect on, and I'm sure everyone else here does as well. There's so much to think about. So really, thank you so much. for that. And again, thank you, everyone. And yeah, have a great evening. See you around.
Thanks, folks. Take care. Have a good one.